Greetings and welcome, friends. Mr. Wada here. We are taking a look at page 243. What a number. Isn't that just, wow, amazing. I love it. And we are talking about triangles and really just polygons and congruence. And man, I'm excited. We are getting into the thick of it now. We are in the jungles of geometry. I'm so pumped. I just am pumped. So let's see. It says in these exercises, triangle XYZ is congruent to triangle MNL. Copy and complete the statement. I already copied and pasted, friend. And here's question 5. The measure of angle Y is equal to what now? What now? So let's see. All right, 124 degrees, because corresponding parts of congruent figures are congruent. What?
Is there like a theorem or postulate?
Yeah, corresponding parts of congruent figures are congruent.
Well, obviously.
More frequently, we'll be referring to corresponding parts of congruent triangles are congruent. Say, pay, say, tay, say. But we don't know that one yet. Yeah. So here we go. The measure of angle M. Let's see, what's the measure of angle M? Well, let's see. Do I know if it, guys, does it correspond to Z or does it correspond to X? How do you know? But how do I know this wasn't just a mirror? It's because of how it's written. Perfect. Thank you, Haley. All right. M corresponded to the X. All right. Excellent. Man, that was amazing. 33 degrees.
Wait, can I explain why?
Yes.
That is the corresponding point
Corresponding parts of congruent figures are congruent. I agree. The measure of angle Z. Yeah. I took some math classes with an Australian once, which, by the way, 8 hours of math, 5 days in 1 week, finishing an entire course. It was far more entertaining with someone with an interesting accent. All right, so thank you for your participation, friends. Good game or whatever.
GG.
Yeah, GG. GLHF, as they say when you start a StarCraft 2 match.
Good luck.
Yeah, that's what I said. GLHF. Good luck, have fun. Yeah. So, measure of angle Z. Guys, does someone have a suggestion for how we could find the measure of angle Z? I know that it's congruent to the measure of angle L. Lily, thoughts? Okay, so that adds up to like 157. And then what? Okay, so 180 minus 157. So what's that, 23 degrees? Did I do it right? I think I did. I'm saying that I did. So 23 degrees is what we end up getting. The reason that's true, we could have said third angle theorem, tat, 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 right? There we go. How about XY? XY is congruent to MN. Ooh. Okay, which is, there it is, which is 8. Yeah, very good. Very good. All right, I like it. I like it a lot. Here we go. Question 10. Now, one of my friends in real life, who will remain unnamed, said that question 10 was a good, tough problem. So I'm looking forward to this one. Here we go. Oh, let's see. I've got to sign something. Here we go. All right. And then, yeah, just shut the door if you don't mind on your way out. So, here we go. MNP is congruent to TUS. All right. So here's an equation that relates X and as an angle measure. All right, so here we go. Angle U, Lauren, corresponds to angle N. Oh, but that's unfortunate. I don't know the measure of angle N. How could I find the measure of angle N, friends? I think it's like third angle theorem. I think I can do 180 minus, try some. All right, friends. 142 plus 24. Yeah, Malik, you can go back to your seat though. So that's 166. And so that's going to be, what? 14 degrees?
Yeah.
Is the measure of angle N, right, Malik, in your seat? And so therefore, 2x minus 50 is equal to 14 degrees. The reason that's true is because corresponding parts of congruent figures are congruent. All right, did anyone get this far? Do you at least see how I got this far? All right, okay, all right. So sometimes it's just a matter of like seeing and practicing and rehearsing enough of these that your brain starts to recognize and create its own pattern system. So let's solve for x. So I'll add the 50 to both sides. I've got the 2x is equal to 64. Divide both sides by dose. Nope. Nope. And x is equal to 32. So there's my x right there. But now I've got to find the y. Now, y is in an expression that is referring to the length of NP. I'm going to say that NP is congruent to which line now? Which segment?
S4.
NP is congruent to us, actually. U plus me equals us. And if those are congruent, then their measures are equal. So I'm going to suggest that 2x minus y is equal to 13. And let's do some substituting. Oh, man. I got confused. There we go. It goes in for the x. Man. So 2 times 32 minus, what is that, Y or something like that? I don't remember. Wow, that's like the longest letter sound name ever. And let's see, subtract 64 from both sides. Oh dear, friends. Negative y equals, what's that, negative 51? Oh, I didn't swap my colors back. I gotta have the right colors. So the opposite of y is equal to negative 51. So what's positive y equal to? Positive 51. All right, no one noticed any mistakes in my logic or my algebra or my arithmetic? I don't think so.
There were 12.
There were 12 mistakes? Okay, I was like, whoa, man. All right. So let's see, here's question 12. Question 12. Let's see, I've still got to take attendance, internet friends, but I'm not going to read the names of my students off on the interwebs. So let's see, here we go. Show that polygons are congruent. Explain your reasoning. Let's see, how about this? What? You saw me swap that, didn't you? You guys saw me swap that. Y dubs is congruent to WY. The reason that's true is reflexive. All right. I think I can say that this angle is congruent to this angle. Can anyone name those angles for me, first of all? Wait, did this just switch back from yellow to red? I don't know. Angle, what's the name for this angle? I can't just refer to it as angle Y because that would not be distinct enough to identify the one I'm talking about.
XYW.
XYW. And that is congruent to angle ZWY, ZUI. Yeah. And why are those congruent? Alternate interior angles theorem. We're getting familiar with that one, right? I hope you are. I hope so. And does someone have another statement we could make? What's the third, the next corresponding pair of things that I have to congruate? Looks like another pair of angles. And I would say angle ZY dubs is congruent to angle XWY. And the reason that's true, alternate interior angles theorem again. Man, I just can't wait to get to this proof. And then I think I could say that triangle XYW, or any other triangle name that makes up those three letters, and there are 6 possible or combinations of that. But now that I've committed to this arrangement, what is the only arrangement that I could congruentate that to? What would the letter combos be? XWY was congruent to... No. You're talking about the same triangle, but in the wrong order. You got to match the order that I gave. Yeah. Z, I agree, yeah, because Z and X are congruent. W, because that's congruent to Y, and Y was the middle letter. I like it. All right. And because all corresponding parts are congruent, something like that. All right, let's get to the awesome proof. Here we go. Look at this. This thing is a thing of beauty. I love it. I love it, guys. Look at this. Amazing. All right. So the 2 triangles that we've got going on here, just in case you are not aware, sometimes it's not a bad idea to draw them separate, okay? Just so you can kind of like visualize a little bit better who we're talking about. Come on. You guys all saw me click on the fuchsia there. All right. C, D. The internet will tell me. They'll comment and say at, you know, whatever seconds of this video, 12 minutes and 13 seconds that I clicked on the, yeah, we'll see. The evidence will be there. So let's see. So these are the triangles I know. I already know in terms of congruence, this is congruent to that. I'm just going to actually start off with just saying given for, right? I'm not going to take the time re-givening those things. We know that this is congruent to that. We know that this is congruent to that. Now, check this statement out. Let's see. Do I have another? I'm going to say that BG is equal to, nope, oh, I said it wrong, guys. BG, the number representing its length, is equal to BE plus EG. I'm also going to say that CF is equal to CE plus EF. Why are both of those statements true? BG is equal to this plus that. Segment addition postulate. Seg add post. Good. All right, so that's for both of those. So we've just proven this and this. Okay? All right. I think I can say that angle G, actually, well, I was slow to say, let me, okay. All right, wow. I've got like a few more lines before I can actually justify that, don't I? That, by the way, that looked like an awesome like football that I just drew. Anyone agree? No? No. Oh, like bread? Like Minecraft bread? Delicious. Now, so, okay, so you see where I'm going here. How can I get to this point where I can say those 2 segments are congruent? I need to somehow show that, like, these are the same thing. Let's see. Well, I know that BE is congruent to all of the others. So I think I could actually say BG is equal to BE plus BE. And I could say CF is equal to BE plus BE. If I just do a whole bunch of substitution, like 3 substitutions, all right, where I just like substituted in for here and here and here, using the fact that BE was congruent to all of those. All right, do you guys read that? Mm-hmm. And then where do I go? I go BG is equal to CF. How could I combine these 2 statements to get that? Transitive property or substitution property? I thought you spelled my name wrong. I was like, water? That's not even close. Wow. Man, so we'll just call that transitive property, right? If this is equal to that and that is equal to this, then they are equal to each other. And therefore, BG is congruent to CF, def of Cong. All right, we're still moving here. Okay. I'm going to say FG is congruent to GF. All right, this guy right here. You see what I'm talking about? How can I make that statement? Actually, I should label it like that and that, sorry. That is true because of what? Reflexive. Okay. All right, here we go. I'm going to go, I think for sake of time, I'm just going to like verbally communicate this part. Ready? Follow along. This is going to have some ... AG is equal to AF plus FG. Agreed? DF is equal to DG plus GF. Both of those are true by segment addition postulate. Then using substitution, I could substitute one of those for the other in each other's statements. And then I know that like this plus that is the same as this plus that. And then using another transitive property, I would end up being able to say AG is equal to FD or DF. And then by def of Cong, I'd be able to finally conclude that AG is congruent to DF. All right, so many of the same types of arguments, but yeah, there was seg add, there was substitution, there was transitive, and then it ended all with def of Cong, def Cong. All right, so yeah, I just want to like try to make sure we have time for today's lesson. Okay, so I just proved this. 1, 2, 3, 4, 5, 6. How about this? How about this? How can I prove angle G? I guess, no, in this sketch I would have been able to use just that name, but here I've got to be a little bit more specific. Oh dear. Oh, you guys just saw that. Let me scroll back down. All right, that's not the same one. Man, this is a long homework video. I got to keep going. All right. There we go. All right, so angle G, I'm talking about BGA. Nope. Guys, whoa, it keeps twitching on me. You see that? Yeah, I'm not even streaming on Twitch. Okay. This is like getting ghosted here. BGA is congruent to angle CFD. That's the third angles theorem. All right, you guys agree? And now, which 2 triangles can I say are congruent? Let me make it tricky for you. Let's say I want triangle GAB is congruent to what? Triangle GAB would be congruent to which triangle? Come on, participants. FDC. I like it. Malik from his seat. FDC. And the reason that's true is all the corresponding parts are congruent. All right. All right, let's get out of here, internet friends. Bye-bye.